So here we'll do a quick review of functions we use to process a list. The first example here in the first bullet is to specify all the elements literally. And in that case we use the single quote operator, which says do not evaluate, but just take it as is. So here you can see we have the list with two sublists with strings and numeric values. The next bullet we'll look at here is basically using the list function. The difference between single quote and the list function is that list will evaluate the items before it creates the list. So here you can see that we have A assigned to 1, B assigned to 2, and then within the list function we have two arithmetic expressions which then result in the list containing the number 5 and the number -3. Now if we want to update a list, we can either add an element to the front of the list using the cons function shown here in the third bullet. Here we have a result list containing the numbers 2 and 3. We then say result equals cons 1 onto result, and we see that we have a new list containing 1, 2, and 3. And the last bullet here, we're actually looking at merging two lists together, and in this case we'll be using the append function, where we take in this case one list and a list and merge them together using append to get the resulting list containing 4, 5, 6, 1, 2, 3. Here we'll examine the use of the foreach mapcar function. Its basic purpose is to build a list one-to-one with a corresponding base list. And the body of the foreach mapcar loop computes each element in the new list based on an element in the base list. So in the example here, we'll have an initial list L, just assign the values 1, 2, 3. We'll compare and contrast the foreach and the foreach mapcar loop. We're already familiar with foreach in that foreach says grab each element out of L, assign it to the variable x, and then do something with it. So in this case we're just going to square x. But you'll notice as we go through the loop we square x, but foreach just returns the list it worked on. So any of the work we did in that loop, in this case squaring x, is lost. Now it wouldn't be if we did some bookkeeping, but a simpler approach might be to use foreach mapcar. Here we see the same basic loop, but instead of just foreach we use foreach mapcar and then grab each element out of the list L, assign it to x, and then square x. And then what you'll see is the result that gets assigned to the variable squares is actually the list of squared elements from the original list. So the input list is 1, 2, 3, and the output list is 1, 4, 9. Here's an extended foreach mapcar example. So let's suppose we want to build a list of the window titles for all the open windows in our environment presently. We're going to use the foreach mapcar function together with the HIGetWindowList function and HIGetWindowName. So here in the example, the first thing we would do here is write a foreach mapcar loop. The input list is collected from HIGetWindowList. Now HIGetWindowList will return a list of window IDs. Okay, so we grab each window ID and we call HIGetWindowName. So it converts that window ID into an actual window name. So instead of just like window ID 1, we actually get the name of that window, which would be like, Virtuoso Editing Mux2 Layout, for example. So we'd have that complete window name. And so as we go through the loop, the input list is window IDs, and the output list that foreach mapcar collects for us is window names. And that gets assigned to the variable WinNames. Now as an alternative to foreach mapcar, let's say we didn't know about the existence of foreach mapcar and we just knew about foreach. We could still do this. We would be, however, responsible for collecting all of the return results. And in order to collect them, we would use, in this case, the cons function, which adds elements to a list. So in addition, and this is I guess somewhat trivial, but it would be in reverse order. So if we wanted to be in the original order that we had the original list, we would use the reverse function at the end to make a copy of the list in the correct order. So this example, we have to set our list initially to nil. That's the list we'll be collecting the names into. Then we do our for each loop. We do the HI get window list just like before. We assign it to the window ID variable. And then in the loop, we use cons to get the window name and then add it to the list window names. And so we continue to do this for every item in the window list, and then eventually we end up with the list win names. After we go through the whole loop, we put every window name into the list, but in effect, by putting the most recent one on the front of the list, when we get to the end, we've essentially reversed the list because the last thing in the list is now the first thing in win names. So to be completely accurate with the original one, we would have to reverse that list using the reverse function. So you can see here, if we didn't know about foreach mapcar, we could still write this code, but it would not be as clean and as efficient as using the foreach mapcar function. Now the mapcar function itself can be used independently of foreach. You can double check the language reference manual to see more details on that. So how the mapcar function works is it accepts two arguments. The first one is a function of one argument, meaning it's the name of a function, and the second one is a list. Now the mapcar function then invokes the function that you supply for each element of the list and returns the list of results. So here's an example of our foreach mapcar first. Foreach mapcar x in the list 1, 2, 3, 4, go ahead and square it. So we'll get back the squared result of that list, which would be 1, 4, 9, and 16. Now if you wanted to do it with just mapcar, first you would define a procedure called tr square, and that would take one input and then square the result. So tr square would simply square the result. Now that's the function you want to basically map into each element of the list. So you use mapcar in the second line here. The input function name is tr square that you defined above, and you put a single quote in front so that it does not evaluate that function like a variable, but actually just passes in the name of that function. Then you supply the list 1, 2, 3, 4. It does the work of squaring it and then returns the result 1, 4, 9, 16. And you have the same result as the foreach mapcar above. Next we'll look at filtering lists. The setof function makes a filtered copy of a list including all the elements that satisfy that given filter. So for example, here we can build a list of the odd elements in the list 1, 2, 3, 4, 5. So you see we have a larger list as input and we have the filtered list or a subset of that list as output. Now in this example, we'll just use the odd p function, which will tell us whether or not a given numeric value is odd or not. So in this case, setof x in the list 1, 2, 3, 4, 5, test each element in that list for whether it is odd or not. So odd p of x. So in this case, the x each time is like a loop. The first time through x gets the value 1. It's then tested. If it is odd, which it is, then it's put in the result list. Second time through, it grabs the number 2, places it in x. X is then tested with the odd p function, and in fact is not odd, so it is not included in the output list. We do the same for 3, we keep it. 4, we discard it. 5, we keep it. So you can see based on the test, we keep those items which match that in the output filtered list. So we'll look in a little more detail here at what the setof function actually accepts as input and actually does. So it accepts a local variable that holds a list element in the filter expressions, then the list to filter, and then one or more expressions that compose that filter. And then for each element of the list, again, this is like a loop, the setof function will bind each element to the local variable. so each element of the list. Evaluate the expressions in its body. So there could be some expressions prior to the last expression to do some, say, calculations or lookup or whatever you would need to do. And then the last expression it uses to determine whether or not to include that element. So that last expression is essentially the filter. In other words, if it tests true or non-nil, it will then be put in the output list. If it tests nil, it would then be excluded. And so the net result is the setof function will return the list of elements for which the last body expression returned a non-nil value. Example of using setof. So let's say we want to retrieve all the rectangles in a design. Here's an example of using setof to do that. So first of all, we'll capture the window cell view into the variable CV using the function GEGetWindowCellView. So whatever cell view you currently have open and as your current design window will be captured and saved into the variable CV. And from there we can look at the shapes in that design. So in this case we would say setof shape is our local variable. The list we're going to process is called CV_shapes. This is a database query. The test then of what we want to use as the filter would be to grab each shape and look at the object type attribute on that shape with the query shape_obj type, and then test that using the equivalence of operator to say, is that object type equivalent to the string rect? Because that's the object type that's stored on every shape that is a rectangle. So basically going through that list of all the shapes, we then test which ones meet the criteria of being a rectangle, and then our resulting list that we return from setof would be the list of only objects which are rectangles. So to summarize here, the CV_shapes expression retrieves the list of the shape database objects, and the shape object type equivalent to rect expression will return the T or nil and essentially perform the filter for us. Here's another setof example. Suppose we want to compute the intersection of two lists. Basically find the elements that the two lists have in common. So one way to proceed is to just use a couple of for each loops and use the cons function to accumulate the common elements. So we have a procedure defined as tr intersect, taking in two lists, list 1 and list 2. Then in the let statement we will identify the result as a local variable. Then we will have a for each loop that goes through each element in list 1, and when it is a member of list 2 we will put it onto the result list with the cons function. So basically we grab each element in list 1 and then test if it is a member of list 2. If it is, we keep it and put it in the result and then return the result as the final result of the procedure. Now using setof, we can have a little more efficient approach to this particular program. For example, in the second case here we have the procedure tr intersect. It takes in two lists, list 1 and list 2. And then using setof, we can basically say, give me the set of the elements in list 1 which are members of list 2. So we use the member function to test each element from list 1 and determine if it is in list 2. If it is, remember setof keeps those that meet that condition, or basically filters it. So the resulting list is just the common elements between list 1 and list 2. Next, let's look at combining setof and for each mapcar together. So we'll be transforming elements of a filtered list. So first of all, we're going to use setof to filter the list and just select the items we want. And then we'll use for each mapcar to manipulate each element in the list. If you look in the notes section, you'll see a little example of this. It's called procedure tr list of squares, where we have a list as input, We then first filter the list using setof, selecting just the odd elements of the input list, or the odd numbers. And then we use foreach mapcar to go through each of the elements in the filtered list, which are the odd elements, and square them. So we have an input list of 1, 2, 3, 4, 5, 6, and then we have an output list of just the odd elements squared, or in this case it would be 1, 3, and 5 squared, so the output list would be 1, 9, and 25.